Okay, exciting times today. We're going to go over y equals mx plus b. Y equals mx plus b, my friends. This is the beginning important part of graphs and functions and everything we're doing in this section of math. We just went over writing points and plotting and reading points. Pretty straightforward. You might think, oh, this is fun. This is going to be a fun section. This one might be a little bit intimidating, but once we get over this hurdle, you're going to see how easy it is. Okay, so y equals mx plus b is an extremely important equation. It is called a linear equation. Now, we're going to go over a couple of examples of how they might look like. This is just the formula, okay? Y equals mx plus b. You need to know two things in this formula, which is m and b. You need to know from this point forward. I'm going to be asking you whenever I do talk with you or meet up with you online. I'm just going to be like, hey, what's M? Hey, what's B? And you got to know it. Please memorize this. M from this point forward is always going to be slope. And B is going to be your, oopsie, that's ugly, Y intercept. What's your M? Slope. What's your B? Y intercept. What is all this, Neil, that you're even teaching us? You're probably confused right now. Here's the thing. When you are given lines on a graph, so when we're dealing with graphs, and they give us a line, what they're going to ask you at times is, what is the linear equation of that line? Now, that might sound foreign, or might sound like a different language, right? But it's actually pretty straightforward. It's just saying, what is the name of this line? You must decode that line and give me it in mathematical terms, right? And that is what the linear equation is. Every line that you're given, whether it's like that, whether it's like that, whether it's like that, each one has its own unique code to it. It has its own unique name. It has its own unique linear equation, all right? That linear equation is in the format like this, y equals mx plus b, okay? M being slope, b being y-intercept. We're going to tackle what each of those specifically means, the m and the b. But in today's lesson, I just want to give you a rundown on what all the tricks you need to be master at in terms of y equals mx plus b. So, you know what y equals mx plus b is now. It's just a linear equation. The first thing I want to show you is we're dealing with another equation here. Like I said in the quadratic equation, quadratic formula lesson, there's different types of equations. We went over multi-step equation already. 2x plus 3 equals, let's say, 5, right? This is a multi-step equation. You have to split the sides, simplify each side, move every like term with each other, then divide. Then we dealt with a quadratic equation, which, if you recall, how do you differentiate a quadratic equation from a standard equation or a multi-step equation? It's the power. One of your variables has a power. Now we're dealing with linear equations. How do we know we're dealing with a linear equation? It might not even be in the format of y equals mx plus b. It might look like this. All right. This is the linear equation. How do we know when we're dealing with linear equations? We know we're dealing with linear equations when we see an x and a y involved. All right, when we see two variables. If you look here, if you go back to our multi-step equation, it didn't matter whether this side had an x too. It didn't matter how many x's there were. There was only one letter, technically. There was only one variable, right? X's. It could have been multiple x's, but at the end of the day, it was just x's everywhere. How do you differentiate a quadratic equation? When one of your x's, one of your variables, has a power, right? But if you notice, it's still just one variable. There's no x, there's no y, there's no z, there's no other letter. It's just one letter technically. How do you know when you're dealing with the linear equation? When you see two letters, but two specific letters, an x and a y. That should tell you this is a linear equation. I'm dealing with graphs. I'm dealing with lines. Holy crap. When that happens, when you see that you're dealing with the linear equation, you might even know it's a linear equation because they ask you in the question, what's the slope from the following linear equation, or whatever the heck it is, right? Chances are you're going to be given some hint that it's a linear equation. But when that happens, your mind's going to be going everywhere like, oh my god, graphs. This has to do with lines. What do I do? This is where your best friend comes into play. Y equals mx plus b. This is your friend. Y equals mx plus b is your friend. Like I said, we will be mastering in the next 2 lessons slope and y-intercept in particular, but we need to first master when we're given a weird looking linear equation or other specific type of linear equation. We need to master in today's lesson how to morph that into our best friend, the y equals mx plus b form, okay? It's actually called the slope-intercept form. That's y equals mx plus b's legal name, right? Slope-intercept form. But I just always say y equals mx plus b, y equals mx plus b, just because it gets it burned in your brain. When I tell you what's the one equation, what's the one formula that's going to save you? Who's your best friend? You're going to be like y equals mx plus b. So what we need to do is master how to convert ugly looking linear equations that look so confusing, and we need to learn how to morph it into y equals mx plus b. Why do we need to do that? Is because when it's in the format of y equals mx plus b, it's a lot easier to graph the line. It's a lot easier to read the line. We can visibly see the y-intercept. We can visibly see the slope. Y equals mx plus b is our friend. That is why we're going over that today. So now let's get into how to morph a linear equation into y equals mx plus b. This is a very, very important technique you need to do. Let's just stick with this one. This one's easy. All we need to do is use our skills of multi-step equations. Again, algebra is creeping up here, you guys. It's extremely important. All we need to do is, if we know our end goal is to make it look like y equals something x plus something, that's what y equals mx plus b essentially is. Remember, the y and the x are always going to be there. The m and the b is your slope and the y-intercept. Those are the specific numbers, right? Based off of the linear equation. Those are going to differentiate. But essentially that's what we're looking to do, is a number here and a number there. So let's do that. We know we want it to look like y equals mx plus b. I'll put our best friend up here just so we can visibly see. We need to find our y equals mx plus b. We need to morph it. So this is how we do it. Split the lines, right? Essentially, yeah. We want to move stuff till it looks like y equals mx plus b. I know I'm going to move this 2x over there, because if I notice, the mx, the letter with the x, needs to be on that side of that side of the equal sign. So I do that. I move the 2x. Minus 2x cancels out. It can't go underneath here because it's not its like term, so it just gets thrown to the side here, making 3y equals 5 minus 2x. Okay, we're getting places. We're slowly getting there. It's slowly looking like y equals mx plus b. I might need to rearrange some stuff, but something extremely important, the y still has a 3 next to it. If I recall my formula, the y is always empty, right? That is the key there. Y must always just be y, just a positive 1 to the side of it, not any other number. So how do I leave y by itself? Do you remember this? You divide by that. Boom. Now, this is your first lesson. Usually, you only have one thing on that side you have to divide by, right? That's what our equations has gone up to. But in this specific case, something that you never known is we only divided the one thing on that side because there was only one thing. But in this case, there's multiple terms on that side. What you've never known is that when we go to divide by that number, to detach it from the letter, to leave the variable by itself, essentially everything on that side is supposed to be divided. Everything by that number. Now you know, not a biggie. So let's do it. 5 divided by 3. Here's the thing. You could do that on the calculator. You could come out with the decimal. But in the world of graphs and in most math, they like leaving stuff in fraction form. So just leave it as a fraction. And I know that's as simplified as it gets. You know, if you were to do 5 divided by 3, you get 1.667. Make sure you convert and it stays the same, 5 over 3, right? That's as simple as it can get, right? And the same thing with the 2 over negative 2 divided by 3. It'll give you a long decimal. You just convert and it still gives you 2 over 3. This is essentially your answer when you divide by 3 on both sides. Does it look like y equals mx plus b? Similar, but a little different. All I got to do is rearrange. Remember, y equals mx plus b. The mx comes first and the b, the y-intercept, comes next. So I'm just going to rearrange it. This one has to be in the front. This one is a positive 5 over 3, so I'm going to do a plus 5 over 3. And this is my final linear equation. Oopsie, bloop. Complicated? Let's do some more examples, my friends. We're just using our skills of algebra. That's all we're doing. We got a couple ones here. So we're just going to do a couple of this, not all of them. Let's do the first one. The first one seems a lot easier. Y plus 14 equals negative 4x. So this one's actually the simplest one of all. All I got to do here, if you've noticed, is minus the 14. Can't go underneath there. Just goes to the side. And we're left with the literal answer. Do you see that? Y equals mx plus or minus, the operation never matters, plus b. So y equals mx plus b. I've located the answer. I've morphed it into our best friend, y equals mx plus b. Let's do the next one. I don't want to do 2 because that one looks pretty easy as well. Let's do a challenging one with fractions. So let's go with 5. Although it doesn't have a fraction, it's totally fine. This is similar to the one we just did as our first example. So what do we got to do? We want to morph it the way it is. We always got to move the stuff first before we ever divide. So we move that to that side. Negative 2y equals negative 7 plus 6x. Alrighty. Then we divide by negative 2. Everything on that side gets divided by negative 2. That is what leaves the y by itself, leaving a positive 7 over 2 plus 6 divided by negative 2. That gives us a whole number. That's not a fraction. That gives us a whole number. It actually gives us negative 3x. There you go. Just rearrange it so it always looks like the mx comes first and then the b, the standalone number, or in this case fraction, doesn't matter. Fractions are technically numbers. Make sure that's always on that side, and boom, you have your linear equation, your y equals mx plus b. Again, this is the slope-intercept form. Y equals mx plus b is the slope-intercept form. And you do have that on your GED formula sheet, my friends. If we pull it up, our GED formula sheet, we could look down below, and what we see here is slope-intercept form of equation of a line. It is right there. Y equals mx plus b. But there is another form, the point slope form. Like I told you, there's multiple forms, and that one looks too ugly, right? So this is what's the point of the whole technique of me showing you. I do have an example here. Here's a point slope form. Whenever you're given point slope form, especially on the GED test, just don't deal with it. Just convert it into a y equals mx plus b, into the slope-intercept form, because it's a lot easier on your eyes, trust me. So let's just do this one. Let's practice morphing. Let's practice morphing point slope form linear equations into slope-intercept form. What do I got to do? This one's a lot more complicated, but you split the sides. Nothing to do on that side. Can I do something on this side? Heck yeah, I could distribute that, right? y plus 4 equals, what's negative 5 over 2 times x? That's just negative 5 over 2x. What's negative 5 over 2 times negative 2? You're just like, I don't know how to multiply fractions, da 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 da. Not a biggie. You have a calculator. All you got to do is do the fraction form. Boom, boom, boom. Negative 5 over 2, go to the side, times negative 2, and then boom, positive 5. You let the calculator solve it for you. Go look at the video on how to download the GD calculator at the first module. So now we have this. Each side is simplified. Now what? Remember, the end goal is to morph it into y equals mx plus b. So what do I need to do? You got to locate what you need to do next. Well, I want y by itself, so I think I got to move the 4, right? Yes, and it goes underneath its like term. Y equals negative 5 over 2x plus 1. And just like that, I have my y equals mx plus b format. I've converted from point slope form, which is that one right there, to slope intercept form, our famous y equals mx plus b. In the worksheet, make sure you go through each linear equation that I gave you and morph it into slope intercept form, aka y equals mx plus b, because the lessons that come after this is going to be diving into m and b in particular, the things that this whole linear equation does for us. That's what we're going to master next.